For this skill, we'll be looking at exponential functions, specifically growth versus decay. Before we look at growth versus decay, we need to discuss decimals versus percents. So when you convert a decimal to a percent and a percent to a decimal, that's going to be important as you write exponential equations. If you convert a percent to a decimal, you need to take that decimal and you need to move it to the left twice. Or another way of saying it is dividing it by 100. If you're going to convert a decimal to a percent, you need to take the decimal and need to move it to the right twice. Here's the view of three of the functions that we've been looking at throughout Algebra 1. You have a linear function, quadratic function, and an exponential function. We're going to be focusing on the exponential function. So the exponential function has two aspects. It has an a, which is a coefficient, which is also where your y-intercept is at. And your b, which is your base, which is your multiplier. Not to be confused with the b that's in a linear function where y equals mx plus b, where that is your y-intercept. Here, your a aspect is your y-intercept. The b is saying, what am I multiplying by to get to the next value? So just to give you the heads up, if we look at this function here, it crosses the y-intercept at 1, so a will be 1. Look at your y values, 1, 2, 4, 8, 16. You're multiplying by 2. So your base here would be 2, so that would be 1 parentheses 2 raised to the power of x would be this equation. When that base is greater than 1, it's going to be growth. It's going to be getting larger. When your base is less than 1, it's going to be getting smaller, which is often stated as decay. So now let's look at exponential equations and let's discuss how do we know if it's growth or decay and by how much. So now we know that the purple one, this is decay because this base is less than 1. Same thing for the yellow, while the other two are growth. But the question comes up, is decaying or growing by how much though? In order to do that, take 1 minus the base and you get a decimal, which is 0.24. Now convert that decimal to a percent by moving the decimal to the right twice. So that's 24%. We already know it's decaying because the base is less than 1. Now we know it's decaying by 24%. So for decaying, we take 1 minus the base, but for growth, we're going to take the base minus 1. So take 1.24 minus 1, and you get 0.24. Move the decimal to the right twice, and you should get 24%. So not only do we know it's growth now, we know it's growth by 24%. Now, the next one, we know it's decay, but by how much? Oftentimes, people will say decay by 20%, decay by 2%. Neither one of those are going to be correct here. We know it's decay, so we'll take 1 minus the base, and you get 0.8. Move the decimal to the right twice, and you get 80%. So that's going to be a decay of 80%. Now, it's growth, so we'll take 1.8 minus 1, and you get 0.80. Move the decimal to the right twice, and you get 80%. So that's growth of 80%. And if you look at this one, we went through the same structure, and we got growth of 27.6% by taking the base minus 1, because it's growth. And then this is another growth. So we'll take the base minus 1, and we get 0.035. Move that decimal twice, that's growth of 3.5%. Now 0.99, he's like, ooh, that look like it got to be decaying by 1%, 99%. Which one is it? Take 1 minus 0.99, you get 0.01, and move the decimal to the right twice, and you get 1%. So decay by 1%. And the last one is decay, so we take 1 minus that base, and we should get 0.5843. Move the decimal to the right twice, and you get decaying of 58.43%. Please do not forget to convert this decimal to a percent. Oftentimes, when it comes to your possible answer, like a problem like this, they'll say decay by 1%, and that's the correct answer. But then they'll say decay by 0.01%, just to see if you converted the decimal to a percent. So be careful there.